Right, so question 9 then is set out, again, quite simply set out. Doesn't mean it's simple to do, but the question itself is, there's kind of no two ways about it, I suppose. It says solve the simultaneous equations. It gives us 3 different equations to do, to solve them simultaneously. So we just have to pick the order to do them in, I suppose. So we'll start off maybe by doing these two here. So if we take them to the side, the reason we might want to start with those is because the first one has a negative x term, a minus x term. The second one then has a positive x term. So without us having to actually alter the equations in any way, we immediately can see how we can eliminate one of the variables, the x there. We end up with y plus 4z. Next we might take the first two for a similar reason. So the first one obviously doesn't have any variables that will be eliminated quite as easily as the first two equations that we did, but we can see that we still have a positive 2x, and on the bottom we have now a minus 1x. So what we're going to do is we're going to multiply the second expression by 2. So the first one isn't going to change at all. The second one becomes minus 2x plus 4y plus 2z, and that's minus 2. Then solve, so 7y minus 2z is equal to minus 13. Okay, so these are our two equations. So now that we have these two, we're going to take them into the middle here. So we have two equations in y and z. 7y minus 2z is equal to minus 13. We can kind of see here that the easiest one to get rid of would be the z. So we multiply again the second one by 2, just keeping it nice and easy for ourselves, not making it hard. And you could just as easily have decided at the start to get rid of a different one of these letters, so maybe to get rid of the y or get rid of the z, and then obviously your equations would be different to the ones that I'm presenting here. This is just one possible solution, I suppose. So we have 15y is equal to minus, sorry, I forgot to multiply this one here, minus 26. So is minus 15, yeah, and then y is equal to minus 1. Perfect. Okay, continuing on. So we use one of our other equations. Y plus 4z is equal to 11. Minus 1 plus 4z is equal to 11. 4z is equal to 12. Z is equal to 3. And then we go back to one of the original equations that we had. So maybe x minus y plus 3z is equal to 12. We can sub in the two letters that we do have. So we haven't got x yet. We have y and we have z. So we can sub those in. And we'll get that x is equal to 2. So then we can just write these out just to make it again really clear for ourselves, for an examiner, what our answers are. X is equal to 2, x is equal to 2, y is equal to minus 1, z is equal to 3. The key thing with your simultaneous equations is to just be consistent, working your way through it. If you've made a slip at one point, just be consistent, I suppose, and follow it through. Obviously, at the end, if you're a little unsure about your answers, you should be able to sub them back into some of the other equations. So we've only used one or two of them there in solving that question, but you could sub them back into any of those 3 equations at the top, and you should still solve those equations. So no matter what of the 3 we picked the last one, but if we decided to sub our x, y and z into the middle one, or the first one, it should still work out for us, and that's the sign then that we've got the equations right.